Picture this. You open your Cambridge IGCSE Computer Science Paper 2 exam. You're feeling good. You write out a perfectly logical program and you think, nailed it, maximum marks. But the second the examiner actually looks at your code, they immediately deduct points. Why? All because of one silent trap you probably didn't even realize you fell into. Well, today we're breaking down the exact mechanics of Visual Basic console inputs and outputs to make absolutely sure your logic is bulletproof. Let's get right into this explainer.
Take a close look at this code snippet. Dim num1 as integer equals console.readline. I mean, it looks pretty standard, right? You ask the user for a number and you store it. Simple. But what happens if the user just hits enter without actually typing anything at all? You get a null string input. And instantly, boom, you trigger this bright red error, system.invalid cast exception. Your program just tried to cram a blank text string into an integer box, and it completely crashed. This right here is the ultimate exam trap that bleeds easy marks. And trust me, examiners see it all the time.
All right, Section 1, Mastering Console Input-Output. Let's go over the foundational mechanics you need to patch this fatal programming error for good.
To survive Paper 2, you need absolute clarity on two absolutely critical tools in your console application toolkit. First up, console.writeline. Think of this as your program's voice. It's what displays text prompts or variable values directly on the screen for the user. Then you have console.readline, which is essentially your program's ear. It literally pauses the execution of your code, just sitting there waiting for the user to type something on the keyboard and press return. But remember our trap from earlier. Readline always captures that input as a string. Always, no exceptions.
Now here is your ultimate infinitely repeatable sequence for any Paper 2 scenario. Whether the exam asks you to calculate the volume of a water aquarium or figure out the total weight of some grain sacks, you just follow these 5 steps. Step 1, declare your variables globally, setting them to 0. Step 2, prompt the user using WriteLine. Step 3, capture and store their input using ReadLine. Step 4, actually perform your arithmetic calculations. And finally, Step 5, output the result. If you stick to this logical flow, I promise you, your code practically writes itself.
Which brings us to our next vital rule, avoiding magic numbers. Let's say you're converting an aquarium's volume from cubic centimeters to liters, which means dividing by 1,000. Do not, under any circumstances, just drop the number 1,000 into your calculation out of nowhere. Instead, you need to declare a constant at the very top of your program, something like const liters as integer equals 1,000. Using named constants like this makes your arithmetic logic totally transparent. It basically makes your code bulletproof, showing the examiner that you're thinking like a real computational problem solver.
Moving on to Section 2, the Exam Strategy Framework. We're going to shift our focus now from basic coding mechanics to understanding the strict psychology behind the Cambridge mark scheme.
Before we get into the nitty-gritty of answering written questions, I want you to think about something. There is a specific, exact clue that the examiner intentionally hides in the prompt that completely dictates whether you get 0 marks or full marks. Seriously. In a moment, I'm going to reveal exactly what that clue is, but first, you really need the framework that makes identifying it totally effortless.
The absolute foundation of that framework is decoding command words. If the question says state or define, they want a rapid, concise fact, 0 fluff. If it says describe, you've got to give the core characteristics of the concept. But if it says explain, you have to provide the why and the how. A perfect explanation gives a clear reason or a mechanism. Look, if you just describe something when you were explicitly asked to explain it, you're capping your marks instantly, no matter how beautifully you write.
So the million-dollar question is, how do you structure a safe, high-scoring written answer? Just use this strict 4-step template. Always start with the definition of the technical term. Next, outline the mechanism, like how does it actually work inside the computer? Then, provide a scenario example based strictly on whatever prompt the exam gave you. And finally, state the consequence or advantage. If you follow this exact template, every single technical point you make is going to align perfectly with what the examiner's mark scheme demands.
Part of demonstrating perfect logic means proving your program won't just break the second someone uses it. You have to know the 4 types of test data used to validate user input before any calculations even happen. Normal data is your expected everyday input. Abnormal data is invalid or wrong data types, like someone typing the word 16 instead of the actual number 16. Boundary data tests the exact extreme limits of your accepted logic, and extreme data tests the values just barely outside those limits. Validating against these, completely non-negotiable. Okay, Section 3, the Interactive Examiner Challenge. Let's put everything we've talked about into practice and challenge you to apply this new framework to a realistic, high-stakes past paper scenario right now.
Check out this flawed code snippet. If age is less than 16, then console.writeline too young. Honestly, it seems totally straightforward for checking a user's age, right? But I want you to pause for a second and predict, why will this simple if statement fail miserably in the exam if abnormal data is entered by the user at the readline prompt?
Need a massive hint? In Paper 2, 1 mark usually requires one distinct technical point, and you must apply your generic programming logic directly to the scenario's nouns and constraints. Ask yourself, what actually happens if the age input isn't even a number at all?
And here is exactly how an examiner wants you to correct it. Before you ever even hit that if statement, your improved answer must validate the input data type. Why? Because, as we know, Readline brings data in as a string. If the user inputs a blank space or text, comparing it to the integer 16 causes our old friend, the invalid cast exception, to crash the whole program. You secure those top band marks by showing the examiner you validate that the input is actually an integer, maybe using a scenario-specific variable like num under 16 before you attempt any arithmetic.
All right, Section 4, upgrading your final answer. Let's tie the whole shebang together now to see exactly how a high-retention student structures their final response to guarantee full marks using the tools we just covered.
But first, remember that open loop from earlier? I asked you what the exact clue the examiner leaves in the question that changes your answer completely. Let's finally solve that mystery.
Here is the secret: scenario nouns. The examiner is actively giving you specific variable names in the prompt, things like calculating ticket prices for adults versus under 16s. If you write a generic answer using X and Y, you are going to lose marks. You absolutely must use their exact scenario nouns, like num adults and adult income, in your code and in your written explanations. You have to take generic computational thinking and apply it directly to their specific case study variables. That is the ultimate clue to securing maximum credit.
So, let's wrap up our strategy for surviving Paper 2 Algorithms and Logic. Number 1, always check constraints using validation rules before doing any math. Number 2, never ever confuse validation, which checks if data is sensible, with verification, which just checks if data was copied correctly. And number 3, absolutely always apply those scenario nouns to your readline inputs and calculations.
By mastering these principles, you're literally insulating yourself against the most common exam traps out there. If you want to keep excelling in your Cambridge examinations, make sure you subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE.
So, you now have the ultimate framework to handle input and output flawlessly. But what happens when you follow all these programming rules to the absolute letter, construct beautiful algorithms, and still lose marks? Yeah, it happens, and it's because of hidden traps buried deep inside the annual examiner reports. The examiners actually have a whole other set of mistakes they are actively hunting for, and if you don't know them, you're just walking into an ambush. You're definitely going to want to dive into our next explainer on examiner report mistakes to truly ensure your grade is safe. Catch you there.